Hello everyone. Still regarding the size and distribution of a single data. We will study the following topics after quality coverage, which is percentile reach. Now, what is percentile reach? Let's look at the following explanation. Previously published about percentile, which is a value that divides data into 100 equal parts. We'll now learn about the percentile opportunity. Percentile reach, or abbreviated JP, is a collection of data that has the 10th percentile and 90th percentile. The rank of percentiles is obtained from the difference between the 10th and 90th percentile, which can be written as follows. JP equals PS 90 minus PS 10. Information JP equals percentile reach, PS 90 equals percentile of 90, PS 10 equals percentile of 10. To better understand, let's look at an example. Single non-data 5, 7, 9, 4, 3, 4, 7, 8, 5, and 7. Determine the percentile range of the data above. Now, to answer that, remember how to find the location of the percentile with a formula. PSI equals I data times n plus 1 divided 100. With PSI equals I data percentile, n equals amount of data, and I equals 1 until 99. Okay, the first, we will to seek location of PS10. So, with input of the information, I data percentile is 10, and amount of data is 10. So we get location of percentile 10 is 1.1. So we get percentile of 10 equals x1 plus 0.1 times x2 minus x1. Nah, we know x1 and x2 from the single data. x1 is 3 and x2 is 4. So we get the percentile of 10 is 3.1. Once more, 3.1. Okay. In the same way, we get percentile of 90 is 8.6, 8.9. Okay. After that, we input the value of percentile 90 and percentile 10. So, we get the solution of percentile reach is 5.8. Yeah, once more, we get the percentile reach is 5.8. Very easy, right? With this, I believe the percentile reach is complete. Now, we next in the new topic is coefficient of variation. Coefficient of variation is the ratio between the standard deviation and the average value expressed in percentage. The coefficient of variance is useful for observing data variance or any data from the average calculation, in the sense that if the coefficient of variance gets smaller, the data is more uniform or homogeneous. Conversely, if the coefficient of variance is greater, the data will be more heterogeneous. The formula of coefficient variation is S divided x bar times 100%. The information is KV equals coefficient of variation, S equals standard deviation, and x bar equals average count. Okay, we go straight to the example problem. Mr. Robert teaches statistics courses into Class A and Class B. After 8 meetings, the mid-semester examination is held. The data obtained in Class A has an average value of 75. Yeah. Okay, we get the information. In Class A, average value is 75 and standard deviation in Class A is 5.4. While in Class B, the average value is 85 and the standard deviation is 4.2. Yeah, once more, in Class B, we get information average value is 85 and standard deviation in Class B is 4.2. What is the coefficient of each security? Nah, with the information provided, it is very easy to obtain the coefficient of variation by inputting all information into the formula so that it is obtained. Now, we get the coefficient of variation class A is 72% and coefficient variation in class B is 4.94%. Very easy, right? Okay, well that it's just an explanation of the coefficient of variation, and we will proceed to a more exciting topic, the coefficient of variation quartile. So don't go anymore. Don't go So don't go anywhere, everyone.
Coefficient of quartile variation. The quartile variance coefficient is used when a group of data is unknown what the mean value is calculated and the standard deviation OH. The equation of the quartile variance coefficient is KVQ equal Q3 minus Q1 divided by Q3 plus Q1. This is equation 8.1. Or by formula, KVQ equal Q3 minus Q1 divided 2 and then divided met. This equation 8.2 with KVQ equal coefficient of quartile variation Q1 is lower quartile or first quartile. Q3 is upper quartile or 3 quartile. Med is median. Review. A quartile. Data groups that have been sorted and for equal parts are called quartiles. This quartile consists of 3 parts, namely the first quartile or Q1, the second quartile or Q2, and the 3 quartile Q3. So data that are not grouped or single, the quartile value is determined by the formula QE equal n plus 1 divided 4. We can see example this this dart. Write QE equal quartile value E, and then E is 1, 2, or 3. B. Median. The middle value of the short data group is called the median. Usually the median is abbreviated as MED. Media data is not grouping or single that can be determined immediately after the data is sorted. For n odd numbers, n equal 2 key plus 1, and then key equals n minus 1 divided 2. For n even number, n equal to key, and then key equal n divided 2. Okay, friend, because we already know what is quartile and the median of a single data, we can easily calculate the value of the quartile coefficient of variance by using equation 8.1 or equation 8.2. Example: find the quartile coefficient of variance for a data. Elementary statistical exam scores of 50 students of Bunga Mawar University in Northern Sumatra Utara area as follows: 16.5, 15.5, 17, 18, 17.5, 19.5, 19, 17.5, 15, 19, 15, 16, 16.5, 17.5, 18.5. Solution. Now, n or lots of data equal 50. The first thing we do is sort the data from a smaller order to lesser value. 50, 15, 15.5, 16, 16.5, 16.5, 17, 17.5, 17.5, 17.5, 18, 18.5, 19, 19, and 19.5. Then the values of Q1 and Q3 is Q1 equals value of E n plus 1 divided 4, value of 1, 15 plus 1 divided 4, equals value of 4 and equals 16. Q3 equals value of E n minus 1 divided 4 equals value of 3, 15 plus 1 divided 4 equals value of 48 divided 4 equals value of 12 and equals 85. So, by using equation 8.1, QVQ equals Q3 minus Q1 divided Q3 plus Q1. KVQ equals Q3 minus Q1 divided Q3 plus Q1 equals 185 minus 60 divided 185 plus 60 divided 25 divided 145 equals 0.1724137,931. However, if we want to use equation 8.2, then the first step we will do is determine the first and three quartiles. The second step is determining for the median. A first quartile is 60 and three quartile is 85. B median. To find the median, we will first determine the value of k. N equals 2k plus 1. 15 equals 2k plus 1. 2k equals 15 minus 1. And k equals 14 divided 2 equals 7. So median equals MA equals 7. MA is a value that is in the middle after the data, is in the middle after the data is sorted from the summaries to the ledger. M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, M13, M14, and M15. After the values of the first quartile, three quartile, and median are known, we can easily calculate the coefficient of quartile variance using equation 8.2. KVQ equals Q3 minus Q1 divided 2 and then divided median equals 185 minus 16 divided 2 and then divided 70 equals 25 divided 2 and divided 17 equals 12. Equals 12.5 divided 17 equals 0.178571426.
About default value. One of the important benefits of the calculate mean value and standard deviation is that both values can be used to make data transformation that produce standard values. For example, a group of data with values x1, x2, x3 until xn has the calculate mean value x bar and the standard deviation s. We can create a default value of z by using the following transformation. The transformation is this, with zi is default value, x1 is value data group, and x bar is the average value is calculated. Because the values of variable default value are derived from the values of variable x, the z distribution generally resembles the distribution of data x. Mathematically, it can be proven that the distribution of values z1, z2, z3 until zn has an average flat equal to 0 and standard deviation equal to 1. z1, z2, z3 until zn values obtained by means of such transformation are called default values. Standard scores can be used to scale the same from two or more groups of data that were originally on a different scale, so they can be compared. Okay, we study about example. The average value of the final examination economics course in class A with 50 students is 75 and the standard deviation is 10, whereas for English courses in the class have an average value of 80 and the standard deviation is 18. If in that class, Tigor obtained a final examination score for economics is 85 and English is 92. What is Tigor's position in that class? Okay, the solution, we use formula default value. Zi is x1 min x bar divided by s, where x is the final examination value obtained by Tigor. For economics, the default value is 1, and for English, the default value is 0,67. Because the z value for economics is greater than the z value for English subjects, so Tigor's position is better in economics than English.